Okay, so I think that's time. Hello, my name's Michael Newton. You can see up there. I'm kind of MAVNN absolutely everywhere on the internet that I exist. There's a story behind that, but I'm not going to tell it now because that's not why you're here. Why you're here is to break your code, because that's fun, basically. So I'm here to talk about something called property-based testing. It's not a new concept. It's been around for quite a long time. It's not even a new thing in .NET. It's been around for a pretty long time in .NET. But because it kind of has its background in sort of Haskell and Erlang and some of the functional programming languages, it's not something that's really kind of broken into the mainstream .NET consciousness. So I wanted to kind of give you a run-through of what it is and how it works and how you can use it yourself for your own code. And the basic idea is very simple with property-based testing. Rather than picking examples that are true, as you would in normal unit tests, what you're trying to do is you're trying to identify properties about your code which are true. So kind of the archetypal example of this, which everyone uses in their Getting Started guide, and even the .NET library, which I'm going to show you, uses this example in their Getting Started guide, is if you want to build a reversing or a sorting algorithm, then property-based testing is really easy because other people have already written reversing and sorting algorithms, and you kind of have this property you know about it, which is something along the lines of, I still want to sort things correctly, I just want to do it faster for my scenario. So what you can do with property-based testing is you can say, I want my new sorting method to always produce the same result as this old slow sorting method, and the property-based testing framework that you're using will then try and kind of find examples where that isn't true. So, for example, you might find out that your sorting algorithm is not stable, as in if you have multiple copies of the same thing in your list, or things with the same key in your list, it might not keep them in the same order, and things like that. And the even simpler example is if you reverse a list and then you reverse it again, you have what's called an invariant property. You have a property which should be always true for any input. And property-based testing frameworks are great with that because you can say, if I reverse my list and I reverse it again, I should get a list which has the same items in the same order as the list that I started with. And so you can write a nice little property which says, I always want this to be true, and off you go. Now, this is great, and if you're like me, the first time you come across this, you go, that's a really powerful concept, except that I'm parsing badly defined data from a mainframe at the moment, and I don't have any invariant properties. Is this actually any use to me? And the other thing you kind of start hitting quite quickly is that what in strongly typed languages like sort of the .NET languages, what the property-based testing frameworks tend to try and do is they'll take the method that you're giving it, and they'll have a look at the type signature, and they'll have a look at the input parameters, and they will try and generate inputs for those functions based on the types of the input parameters, which is great and all, except that we don't have such a strong type system that our functions will always accept any valid value of the types that we've said. So if you are, say, parsing something, there is probably a subset of the type string which are actually valid things to parse, whereas all of the other strings you're not really expecting to do anything meaningful with. You might throw, or you might give an error message, or you might do something else. So it's a bit hard initially to kind of get an idea of where to go with these. So I've kind of taken two different approaches, and I was originally going to give a quite different talk that I've given before, and I've decided to swap things around a bit. So I will give a link at the end to a talk I did, I think, 3 years ago now, where I go off and I have a look at a whole load of different examples of kind of real business cases where I've used property-based testing to test things that you tend to think of in more sort of day-to-day business code, rather than things like sorting lists or maths algorithms or things like that. Whereas today I just wanted to take one example and go into a bit more depth about how we can sort of build things up from really simple properties that you can just drop into your code, even if you know very little about property-based testing, and kind of eliminate whole classes of unit tests, so you don't have to bother writing them. And also looking at some of the complexities when you actually start wanting to test bits of business logic, where you're wanting it to sort of generate inputs for you, but you also don't want to duplicate the logic from the thing you're testing in your tests. So that can get quite interesting. So let's have a look. That's not big enough, is it? Let's try that. We might need to adjust width of things slightly. Is that fairly readable to people? So the example I'm going to start with is a little templating library. You've probably seen things like this before, where you can have a string with some curly braces with a name inside, and you can provide a dictionary that gives values to swap into those tags so that you can do templates for your HTML or those kind of things. So this is the example we're going to be working with throughout. And this is similar to, it's not exactly the same thing I've done in real life, but this is similar to some property-based testing code I've written in real life, in that it's an example where we are expecting user input that we have absolutely no control over. We do not know what we're going to be sent. And the other thing is that we are probably going to be dealing with users where we want to be able to give some kind of meaningful feedback if they give us invalid code. So we don't want to just throw and crash, which in many cases is actually quite a valid error handling strategy. Here we actually want to give some feedback on what the error is, why it's happened, what people can do about it. And so this is probably a kind of thing that you're fairly familiar with when you're starting a library. So I've got a couple of unit tests, and I've picked some examples out of a hat. So I've said, well, if I have a template which has no tags in at all, and a model that has no replacement values, I should be able to render the template with the model, and I should get exactly the same string out as I put in. We good so far? Good. I was hoping that we'd get at least this far. If I have a template which has a tag in, and I give it a model which has that tag name in the dictionary and has a replacement value, then it should replace it. So we get the updated string. And we have an implementation. So the actual implementation we're starting with is this one. But I thought, for those of you who haven't seen F# before, there's a slightly more imperative-looking version below. So this is kind of in classic TDD fashion. This is kind of the simplest thing I could think of that could work. Kind of. It doesn't work for everything, because we'll see later. So I thought, if I just had one tag, what would I do? Well, probably I'd write a little regex that kind of looks for two opening curly brackets, optionally a space, the name of the tag, optionally another space, and then two curly closing brackets, and then replace it with the replacement value from the dictionary. I've got more than one of these, so what am I going to do? I'm just going to create a new regex object for every key in my database, and do a replace on the text. Now, hopefully, most of you will spot very quickly that this has all kinds of different issues. So, for example, if your replacement text has tags in, those tags might get triggered later by kind of later values going through the dictionary. It's enormously inefficient, and a few other little details like that. But we don't really care. This will pass our unit tests, and in fact, hopefully, this is up and running. Hopefully you can see that we have two tests have passed. So that's the example we're going to work with. And basically what we're going to try and do is we're going to try and build up to a fairly robust piece of code that we have some kind of well-known good properties about. So let's try and add some error handling. So I'm glad most of you have seen some F# before because I am using a few sort of languages which don't, a few features that don't exist in C#. So I've got this idea that I want to try and classify all of my errors because in the problem where I was originally sort of doing something similar to this, I needed to give localized error messages. So I didn't just want a string error message about what had gone wrong. I actually wanted something that I could sort of deal with programmatically later. So I've got this thing called a discriminated union. It's kind of an enum on steroids. And so I can say, okay, well, what's the first level of error checking? The first error of error checking in a .NET library where I don't know anything about the inputs I'm getting is just checking for nulls, null arguments. And the normal technique would be to throw a null argument exception, but here I'm wanting to kind of give localized feedback on what's going on, so I'm not going to throw an exception. I'm going to capture that error and feed it back. So at the moment, I can have a null model or I can have null content. My original rendering library is now been marked as private, so it can't be called directly, and is wrapped with some error handling. So this is a pattern match statement where I have the model, and for some reason I've called the template content, and I have absolutely no idea why my brain did that. So I'll try and correct that before I push the code up to GitHub for you guys. And we just do a little pattern match. So I check whether the model is null. Does this make sense to people, even if you haven't seen it before? So I've got a little guard clause there. And this error and OK thing is something that's actually built into the more recent versions of F#, which is a discriminated union in its own right, where you can mark the result of a function either being OK or being an error. So that looks good. Our tests have changed a little bit. Not a great deal. So there's a couple of things going on. So one is I've given a type alias for this result type that I'm using. So it's in C#, it just shows up as a generic type with a success result type and an error result type. So in C#, you'll either get back an OK of string or an error of a rendering error. And our tests have updated slightly in that now in our comparison, what we're saying here is not just that the result that comes back should be the same string, but that actually it should be an OK result of the same string. It should be a successful rendering of the text. And the result type has value equality, so this equality will only be true if the string inside the OK type is the same in both cases, because the return type here is now of result. And again, our replaced text would be a result of OK as well. Yeah. So again, hopefully this is all still fairly familiar territory. Let's actually bring in our property-based testing framework. So one of the nice things about property-based testing is you can kind of start with simple things, and then, well, simple things to give properties for, and then you can move on to more complex things. So we do actually have an invariant property for our code, which is that we don't want it to throw. We don't ever want it to throw. We always want to give meaningful feedback. So we can write a property that says something like this. Okay, so we're adding a few things here. So the property-based testing library that I'm using is called FsCheck. I'll have a link to it at the end. It's a fairly established property-based testing library in .NET. It's been around for, I think, about 9 years now. It's been around for quite a while. So I've obviously added a reference to that, and I'm using XUnit. It's an XUnit plugin, so I can define properties easily. So that's in there. There is also another newer .NET library called Hedgehog, which came out last year, which I haven't had a chance to play with yet, but all of the concepts we're covering today should kind of apply equally to that. And having added FsCheck, we can start writing properties like this. So they look a bit like a test, but there's a couple of different things going on. So obviously, we've got a different attribute. We're marking it as a property. We're going to call it does not throw. It's got inputs. We're not specifying what those inputs should be. We're not giving any example values. We're just saying, yeah, we want a string to use as a template, and we want a dictionary to use as a model. And then we're rendering the text, and we're returning true. So property, FsCheck, it has a number of things it can kind of consider as to whether your property has passed or failed. The simplest and the most common one is that your property returns a bool, and if the property holds true, you return true, and if it doesn't, you either throw an exception or return false. So here, we're fine, because the only thing we're checking is that it doesn't throw exceptions, so we can just return true, and if it throws an exception first, then, hey, we're good. Now, let's have a look. The only problem with this is that our code no longer passes our new test. So let's have a quick look at what's going on here. Can you see that text, or do you need it a bit bigger? People at the back? You're OK? There's some requests for bigger. Let's see if I can make it a bit bigger. Is it going to let me do that? Because we don't need the details of the stack trace and things. OK, that's interesting. So that's actually one of the errors that I was planning to deal with later, but this is the joys of property-based testing. So what's actually happened here? So it says that the property has failed. It says that the property is falsifiable. So it's found a result where the property is not returned true. That it took 12 tests to find it. So what it's done is it's generated 12 sets of input data, and for the first 11 of them, the property was true. But now it's generated a 12th one, and the property was not true. It then says that it's shrunk it 3 times. So this is one of the nice things about FsCheck. If we look here, so the original property it found, which did not work, is here. So what it's saying is it generated a template, which was the string XNP, and then it's generated, for some reason, it's chosen to display the dictionary as a sequence of key-value pairs. I don't quite know why, but hey, fair enough. So it generated a sequence, one with an empty string and a couple of control characters. I don't know about you, but I probably wouldn't have come up with that as a unit test anytime soon. And the other one, which I suspect is the one that's causing a problem, is it generated one with a key that has an asterisk in it. And obviously, because all I'm doing is I'm taking my key and I'm shoving it into a regex expression, and that's now generating an invalid regex. So, OK, great. And then I get the stack trace and all the normal things you would get because an exception was thrown and so on and so forth. Yeah, so fair enough. Let's have a look at my implementation. It looks like I need valid keys. So I can do something like, so what do I want here? I'm going to want a model. I'm going to cheat and take that. OK, so I'm going to pull all of the keys out of the key value pairs, and I'm going to say that how do we want to make keys valid? I'm going to say a couple of things about it. I'm going to say that whoa, can't type today. So I'm going to say that my identifier has to start with a letter. I'm probably going to have to specify that that's a string. And so basically what I'm just going to go through here is I'm going to get all of the keys. I'm going to check that the first character is definitely a letter, and I'm going to check that all of the characters are either letters or digits. Does that kind of make sense? So I'm double checking the first character, but I don't really care. So I can go what do they call it? Invalid key. Okay, so hopefully we should get a new set of tests at this point, assuming I've actually written that correctly. Oh, yeah, sorry. So it's now just told me that I've tried to index the first letter of an empty string, which it doesn't like. So let's have a check before that to say, okay, yeah, so our key actually needs to have some stuff in it. Okay, so that passed. That's slightly unexpected, I must admit. But let's actually have a look at the kind of things that that's doing. So if we go back to our property for a moment, we can actually have a look at what's going on. Oh, I'm doing that wrong, aren't I? Okay, so let's have a look. It's not terribly useful because it's not showing us a very nice representation of the dictionaries. But you can kind of imagine what's going on with the dictionaries, because what it will be doing is it will be generating the same kind of strings that it's generating for the keys. So we're getting a whole load of strings here. So some of them are empty, some of them are quite short. Some of them are starting to have weird characters in. What you won't see in this display is that it will start generating control characters and things. And some of them will be null. So this is kind of what FsCheck does for you. And let's get back onto a prepared bit. Yes, that's fine. No, that hasn't done what I wanted. Let's go up slightly. So This is a slightly extended version of the code. So this is one of the things about property-based testing you need to watch out for if you say add it to your CI or something, is that depending what properties, what values it happens to generate, by default it runs 100 examples, you might end up getting different things put into your, different results from your tests. So when I was preparing this talk, at different points when I was running the code, I actually got different examples of things that it found that it didn't find the first time. So for example, I found out that, you know, if it gave a null replacement value in the dictionary, then that caused the regex to fail, and sort of a bunch of other things like that. So one thing to be aware of with property-based testing is that it does have the slightly annoying occasional property of you will write some code, you'll get the property-based test to pass, you check it into your CI, and then after a while you'll suddenly get a random error that you weren't expecting. Fortunately, it always tells you what the input was that created that error. So you can go back and add a sort of individual unit case as a regression, an individual unit test as a regression test for that kind of particularly unusual input. Cool. Okay, that's not what I wanted. I wanted my tests again. This is great, and this is actually quite kind of a useful property to be able to write for code. It's just kind of being able to say, okay, give me whatever inputs you like. I should do something kind of meaningful with it. And this is also the kind of property that's quite easy to write if you have the kind of invariance we were talking about earlier. You can kind of see how you could write a property like this saying, I'll sort my list backwards and forwards and all those kind of things. But we don't always, we can't really say very much about what results should be if we're just saying give us any string at all. Because if that input template is null, well, hey, we can't, that's an error. But if it's something meaningful, we would expect it to return okay. And we're just told FsCheck to generate any string at all. It's kind of hard to know what we should be checking here. So, okay, so the first thing that might spring to mind is, so if FsCheck is generating inputs based on the types, how about if we create a type who's has a constructor that makes sure that we know something about the input? So let's give that a go. So hopefully in here, we should now have our tagless string class. So our next property we're going to write is we're going to go, okay, so testing actually that we're getting the correct results is quite hard, quite new to property-based testing. So maybe for the moment, we'll have specific examples for actual genuine templates with real models where we want to do replacements. We'll kind of put some examples in for that. But surely at least we can check that property that if the input has no tags in, it should be unchanged. That's relatively straightforward. So how can we do that? Well, all we need is a string that never has a pair of a double pair of opening braces. Because if it doesn't have a double pair of opening braces, there's no tags. So cool, we're programmers, we can do logic. And we need a type because we're going to kind of indicate to FsCheck that this is what we want. So let's create a class. Class is just going to have a single property on it, which we're just going to call value, which is the string that gets generated. It takes any input string, and then what it does is it just sits there in a little loop for as long as the string contains a pair of opening braces, it loops back round and replaces the pair with a single one again until there's no pairs left. It also does something else, which may not immediately spring to mind, but your property-based testing will tell you quite quickly if you forget about it, which is that later on, we're going to be kind of gluing some of these strings together to try and generate whole template inputs. So if one of them ends with an opening brace and one of them begins with an opening brace and they end up next to each other, we actually end up with an opening of a tag. So we're just going to say that if we ever generate something that ends with a curly bracket, we're going to stick an A on the end. Just, something.
That looks like code to please
No, you would never write code like this in production. This is purely code to generate the kind of input that we want. And that's part of the benefit here, because this code will never have the same logic as the code you're testing. So one of the things we're doing here is that the logic that you need to generate a string that has no tags in is totally independent of the logic you need to parse your template. So you're never going to sort of end up with duplicating your production code in your test generators unless you do something seriously wrong at some point. Yeah, but all we're doing here is we want to put some kind of constraint on the input, which means that we now know something meaningful about the output. And the constraint we've put is there's no tags. And the result of that is that we know that we should get something that, that doesn't change when we feed it through our renderer. The other thing which is nice to do is to override toString to give something nice, because when our property fails, what FsCheck will do is it will tell you which of your tagless strings has caused the property to fail. And obviously, if you don't have that, you just get the class name, which is not particularly helpful. That's our tagless string. And this is where we start to get into slightly more of the magic. So what we have here is we have a new property, and the property is still quite simple. So we get our tagless string as a template. We extract the value, give it to our rendering function, and we say that the result that comes back should be OK rather than error, because that's one of the things we can check. And if it's OK, the value stored in that OK result should be the same as the value that we put in. And if not, we're going to throw an exception that gives a string representation of our error. Is that? Let's get that running again. No. So that's great, but we also have this piece of magic here. Let me just check. Let me see if that runs. Yeah, and it turns out we've got two problems. So one is we've got this piece of magic here, which we'll explain in a moment. And the other is that it turns out, as often happens in property-based testing, that things are not quite as simple as they first appear, because it turns out that actually our property that we thought we had of if we give it a string that has no tags in, it should always work and it should always come back unchanged, isn't actually true, because we also have some constraints on what we consider a valid model. So if, for example, like here, we generate a model that has an invalid key, we still don't get an OK result out, because although our template is fine, our keys in our model are not. So here we have an empty string, so an invalid key has been supplied. So, OK, so we've got a couple of things to sort out. So let's have a look at the magic first. So we've got this thing here where we're now kind of configuring our property, and we're saying this thing here that we want to feed a new arbitrary in. So I'm not quite sure about the naming here, but in FsCheck's speech, an arbitrary is a thing that knows how to create an arbitrary value of a type. And it uses reflection to do that, so we have a generator class that will have members that know how to generate types. So let's have a look at our generator. If my machine doesn't crash, that would be fun. Okay, that's no, it's not liking that. Let's reload that. We'll make it larger again in a moment. Not quite sure what happened there. So let's have a look at our generator. So what we've got is we've got this class. It's got a static member on it, which is of a generic type, an arbitrary of tagless string. And this is how we actually tell FsCheck how to generate tagless strings, because tagless strings is something it has no internal concept of. You know, it has generators for many of the base class values, so it can generate dates, and it can generate strings, and it can generate dictionaries and lists and those kind of things. But this is a class that we've created. It's got no real way of knowing how we want to create it. Now, for this one, we can actually do something fairly straightforward. So what we can do is we can say, actually, we've kind of added some constraints to this, but basically it's just a string. So what we can do is we can tell FsCheck how to convert back and forth from something it knows how to generate already. So we're going to create a new arbitrary based on a none-null string arbitrary. So I'm saying here I don't want null strings, and this none-null generic type is actually built into FsCheck. And basically all it does is you can wrap any other type and say, use your default generator, but don't give me any null ones of that thing. And I can give little lambda functions to convert in either direction. So I can say, if you give me a string which is not null, sort of wrapped in this none-null thing, then I can just call my constructor that has all of the logic I need to remove the tags. And if I want to go the other way, I already know that my string is not null because I'm generating this from a not null string. So I can go, OK, I will convert it back by giving a new none-null. The reason you want to be able to convert in both directions is, as you saw before, FsCheck had this thing where it kind of shrunk the input. So it found a value that didn't work, and then it made it smaller until it found the minimal value that didn't work. And so arbitraries are actually built up of two things in FsCheck. They're built up of a generator that knows how to just generate one of these values, and a shrinker that knows how to reduce the size of the value. Now, the shrinker is optional, so for some of our other examples, we won't be providing shrinkers. But they are quite nice, because it means that when you get the failing test, you always kind of get the minimal version of it. So the default string shrinker, not entirely surprisingly, basically just tries to knock characters out of the string until it finds a version that passes, and then it gives you kind of the last version that didn't. And I think it actually tries to increment back down through the characters as well. So you'll quite often get a minimal error of just the string A, because what it will do is it will start off with a longer string, it will knock letters out until there's only one letter left, and then it will start incrementing back down through the ASCII codes until it gets back to A, and then it will say, hey, lowercase a doesn't pass your test. So you go. So that's kind of the first step of being able to tell FsCheck about your domain. You can create types that represent constraints on your domain, and then you can tell FsCheck how to generate them. And we kind of thought we were done, except we've added these checks that test that all of our input is valid, and our model isn't valid. So that's slightly frustrating. What can we do there? Well, we could do something like, we could take this out and just have a sort of an empty dictionary. But that's not really what we want to test, because there are going to be cases where people are going to send through models with data in and templates that have no tags. It's kind of a valid use case. So let's have a think about how we can generate these. No. Did I already? Sorry, I'd forgotten that modifying the files would cause issues with that. Let's have a look in there. we won't actually. Okay. So this is what your generator starts looking like. So we're going to have an arbitrary of iDictionary. So here we're doing something slightly different. So here we've actually defined our own class, and we're using the class as kind of a flag to FsCheck of sometimes we'll want to generate tagless strings and sometimes we won't. The other thing you can do, and I'm kind of showing this here to show that it can be done, you might want to actually wrap this if you were doing these tests for real, is you can also override the default generators of existing types. So here, for example, I can say, okay, the iDictionaries that I want you to generate, I always want you to generate valid input models anywhere that I use this configuration. So anything that asks for an iDictionary, give it a valid one. So I'm going to override the default generator. So what does it end up looking like? Well, I know all of the first characters that are valid because I've said that the first character has to be a letter. I know that the other characters can be letters or numbers. That's just a nasty little function for sticking a single character and then an array of other characters together into a string. And you end up writing code like this. Now, this is where things start to get a little bit brain-hurty. And this is probably the main concept that I want to go with for today. So if you start to lose the plot totally, do feel free to stick your hand up and tell me. But as you can see, what we're actually doing is we're using a link expression to generate our values. And kind of the way to think about this is that in, say, a link to SQL expression, what you're doing is you're saying is from the context of the database I'm connected to, get me a value that matches these criteria. What we're doing here is we're saying from the context of all possible things this generator could potentially generate, get me one of them. Does that kind of make sense? So this generator here, so gen.elements is a generator that's built into FsCheck, and you can give it an array, and it will generate at random one of the elements of the array. So what I'm saying here is I have this array of characters that are valid first characters for my key. From that space of potential characters, give me one of them. That's going to be my first character. And I can stick generators together. So for the rest of the characters, I want a bunch of characters. I don't care how many, because I've got at least one character now, so I've got a valid identifier. But I want to glue potentially some number of other characters onto the end to give me a variety of different identifiers. So I'm going to say, OK, I've got this array that has all of the legal characters for an identifier. From that array, pick me one of them. And do that multiple times to generate a random array of characters. Is this still kind of making sense to people? Some people are nodding. And then give me one of those arrays. So I'm saying so we've got this kind of generator that can generate any length of array, and the elements in that array will be elements from my valid input keys. And I can also make use of FsCheck's default generators. So I can say, and I need a valid replacement value. So from the generator of non-null strings that's built in, I don't know how that works, and I don't care, give me a string that isn't null, and call it replacement. And then in my select clause, I can do what I need to with these. So this is my merge function that just takes a character, an array of characters, glues them together, turns them into a string. So that becomes my key. And my non-null string, I just extract it from that non-null wrapper to get whatever the string is. So now I have a generator of key value pairs that have valid values in, but I don't want key value pairs, I want an iDictionary. So what I can say is I can say, OK, generate me a none-empty list. Again, this is built into FsCheck. Generate me a none-empty list of key-value pairs. And then in my select clause here, we do something a little bit nasty because we want our keys, we need our keys to be unique. So what we do is if we've generated duplicate keys, we just take the first value that was generated and throw the rest away. And then we build a dictionary of whatever's left. And then the last thing we need to do is now we have a generator of iDictionaries. As I said before, in FsCheck, an arbitrary is a combination of a generator and a shrinker. But I'm just going to use this .from method that basically says, I don't know how to shrink this. I can generate these, but I don't know how to shrink them. So just don't try, basically. So this, I think, is where we really start to see the full power of FsCheck, because what you can do is you can start abstracting things you know about your domain out into these generators, and then you can keep your properties very simple. So our property hasn't changed. If we are given a tagless string and a valid model, then our string shouldn't change. So, our property is still very simple. Someone coming into the code base can come along, they can have a look, and for someone who, even for someone who hasn't used property-based testing, this, for the reader, it kind of looks almost the same as when you do what would be in XUnit a theory, where you then have a list of example values to feed in. It's just that we don't have the list of example values. We're just saying it's always true. It always happens. So this is lovely. And in the last 10 minutes, I'm going to see if I can cover the next bit. And you can get a long way using FsCheck in C#. And as you can see, the code actually looks relatively nice. There is one issue with using FsCheck from C#, which the F# implementation, sorry, it is the F# implementation. The F# language allows you to get around slightly, which is that you have link expressions in C#. But what you cannot do in a link expression is you cannot have a conditional. So you cannot, within a single link expression, say something like, generate me the first character, and if it's lowercase, do this, and if it's uppercase, do something different. That starts getting really nasty. And if you try and actually write something which does that, you'll see that your code immediately kind of explodes. But fortunately, F# allows us to work around this. So I'm going to go quickly across to the F# version of this code to see if we can add something a bit more. So at the moment, this is basically exactly the same as the C# version. So I've got a few type aliases just to make the code a bit shorter. Hopefully they're fairly self-explanatory. We have our tagless string class still. Yep. Yeah.
You just addressed the thing about the readability of the test, which was really nice, and I agree what you said.
Yep.
But what about when other developers come in and see this and you make changes to the production code and you need to fix the unit test? It seems, yeah. Are there any problems there you need to watch out for? It could be a little complicated to go back and understand that generator code.
Yeah. So the question here is, if you actually change a property of your code in production, something that was a property in the past now no longer is, can that cause issues with the generators being hard to understand? The answer is yes, to an extent. But part of the answer is also that if your property has changed, as in if a fundamental property of your code has changed, then probably that generator is no longer what you want anyway. So, I mean, this is something I actually say about unit testing in general, not just property-based testing, that I sometimes have had conversations with people saying, oh, we're refactoring this piece of code. Now a whole bunch of our tests don't pass anymore. We've got loads of work to do. And one of the first questions to always ask is, does that test even matter anymore? And quite often the answer is, well, no, because we're not doing the same thing anymore, so we don't need the same test for it. But yeah, I mean, it's like any other code. If no one understands it, then you have an unmaintainable piece of code. The advantage is it's a test, so you can always throw it away. You can always replace it with a bunch of examples, and you're good. Which is nice for doing things like bringing in new languages like F# as well. It's like you can write the properties more expressively in F#. For production code, people have valid concerns about, hey, no one knows F# yet. We don't want production code we can't maintain. For something like this, it's relatively easy to argue, hey, isn't this a great way to learn? And if I ever leave and no one else has bothered to pick it up, well, you've got some code you can delete next time it breaks. It's not kind of a big issue. Because at the end of the day, most of the value in tests is actually during the creation process. I mean, it's nice to have regression tests as well, but the majority of the benefit is actually up front. It's whilst you're writing the code. Does that? Yeah. So we still got our tagless string. Here I actually wrapped the valid key in a type as well, but it's very similar kind of thing. There's our converters back and forth between different bits. So our tagless string generator. That's kind of the equivalent of the valid key generator, but in F#. So this is kind of what I wanted to show you, is that this is what the syntax starts looking like in F#. So F# has this thing that where you would kind of do from in a link expression, you use this let bang operator. That's kind of a choice that was made. And let bang will do different things depending on this name here outside the curly brackets. So if that said async, let bang would expect the thing on the right here to be an async, and opener would be the result that was awaited for the async. If here I have the gen computational expression, that's what these bits are called, then let bang expects a generator on the right, and the thing on the left is the thing that was generated. Still making sense so far? And the only thing to be aware of here is that what you're kind of doing here with these gen computational expressions is the thing you return here is not a single value, you're actually returning a generator. So what you're building in this block here is you're building the logic to generate something. You're not actually generating a particular value. You're building up the recipe for generating things. And then different testing framework, but hopefully this looks very similar. So we have, in fact, we don't even need any config on that one. We just want to generate any values at all. And you can also do things in FsCheck, like you can actually label the different cases in your properties. So as well as telling you the error that failed, it will give you the label that you've assigned there when it fails. So let's see if in 6 minutes we can have a quick look at how we'd go about generating something that actually tries to prove kind of the correctness of our function, rather than just kind of a simple property about it, like it doesn't throw or something like that. So that's not what I want. Oh, yeah, you want me to reset that now. Okay, so let's have a look here. So this is what you were asking before about, isn't that code really ugly and something you'd never want to use in production? Yes, it is. Don't write code like that in production. So what we kind of want to do here is that we know that if we just generate a model and a template at random, even if they're valid ones, what do we expect the output to be? And if we just say to FsCheck, okay, generate me a model, generate me a template, they're both valid, give them to me in my property. If we then try to write that property to say, is the result correct, what we'd actually end up doing is we'd end up rewriting our production code. Because we'd have to do exactly the same thing. We'd have to parse the input, we'd have to swap in all the values, and then we'd have to go, do we get the same result? Now, that kind of can be valid. One thing I've actually done, which is quite fun, is you can actually get two teams, and we actually did this working in different programming languages, and we just wrote two implementations of the code and property-based test them against each other, which was kind of fun as an exercise, but not an especially efficient use of time in actually writing real code. So what we do is we kind of reverse that logic and go, okay, how about if we think about this the other way around? How about if we get FsCheck not just to tell us the inputs, but also to tell us the expected output? Because in our generator, we know what data we're generating. So we can use those values without having to do any parsing or anything like that. We already have those because we're the ones generating them. So let's kind of have a think about how we might be able to do this. So let's say that our property is going to take this input of I've called it a template situation or a template context here, and it's got the two input fields, but it also has the expected output. I don't want generators. No, wrong one, sorry. So if we have a look at our property stays very simple because we want to render the text of the model and the template, and then we expect the rendered text to equal the expected text that we were given. So that's great, but how do we go about doing that? And this is where the code starts to become really, really ugly if you try and write it as a link expression. Mark Seaman did a whole talk about this yesterday, which slightly surreally is called Dependency Injection Revisited, I think. But it's actually about how writing this type of code in C# is a bad idea, and you should actually use the right tool for the job. OK, so let's have a look. So we want some input data. So we want to generate some key value pairs. We have already overridden this generator to only, so if you remember, we overrid the default generator for the model. So we can just say, go off and generate us one using this arb.generate command, and that will use our override, and it will generate us a valid model. And then we're saying, OK, so what can each piece of the template look like? Well, it can either look like a string that has no tags in which case the output should be the same as the input, or it might be a tag, in which case the input should be like curly brackets and the tag name, and the output should be the replacement value. So for a tagless section, we're good. We kind of have a generator for this. So what we're going to do is we're going to have a generator that returns a tuple of input and output for each type of section. So for a tagless section, we generate a tagless string, we return the values. And for a tagged section, we return a tag and the replacement. And now I can say, generate me a list of either one or the other. Then I can build up a string of the expected inputs and a string of the expected outputs. And then I can return a model that has my data in. And basically, this is the thing I wanted to get to, and that's good because it's almost exactly 20 past. This idea that we can, yes, the generators become complex. Yes, they end up with a lot of logic in them, but it is logic which it is enforced upon you as the person writing the tests, that this logic is independent of your actual production logic. And it can give you really nice confidence of things that you never would have thought of in your tests. And one of the things I do in the other talk, which I will put up on the screen now, is I actually go through a bunch of the kinds of errors that you get that you weren't expecting, how frustrating that can be on one hand, and kind of how much of a game it can become on the other. Because rather than unit tests, where you keep on having to write the next one for your TDD, with property-based testings, you just get the next error. you just write your one property, and believe me, it will take a while to get all the errors to go away. So just a quick run through. FsCheck is there. That's my blog. If you search for FsCheck on there, you'll find a number of examples, including this talk with more examples with less details from a few years ago. And just a quick plug for my employer, who do not use .NET, but do use property-based testing, who are a company called No Red Ink. And I think that's about it. We don't have time for questions, I'm afraid, but come and find me afterwards if you're interested. Thank you very much.
Don't you feel dirty writing this test FS? It's like